All right, 10 a.m. We'll get started. Welcome, everybody. Thank you all for joining us for the next hour here. Got an exciting one today. We got valve operation technology for safety and sustainability. Next slide, please, there, Bert. There we go. Before we jump into it, just wanted to give a little bit of housekeeping. So we've done a number of these presentations over the last couple of years, and what makes them great is the feedback and questions we get from the audience. So please feel free to ask any questions. We'll try to get to some of them as we go throughout the presentation. At the bottom of your screen there's a Q&A section. Just type your questions in there. If we don't get to them right away, we'll definitely try to get to them at the end with that. We'll also have a couple polls throughout this presentation, and they'll be popping up on your screen. Again, would love to get your feedback as those pop up there. Next screen, please, Bert. Just a little bit about CGIS. So CGIS, we obviously, our vision here at CGIS is a world without valve problems. One of our, and then within our mission statement, we look to be the trusted control, isolation, and automation valve partner, and the recognized leader in providing powerfully intelligent solutions to our customers' severe service needs. Further to that, though, we look at delivering superior reliability and significantly improving customers' bottom line safely. And I think safely is one part that we really want to focus on in today's presentation with the way we approach our customers. So this presentation will definitely look at some safety aspects with valve operations, and we'll be focusing on that. Next slide, please. So joining me today and presenting on the topic is Bert Johnson. Bert is with SOFIS. He started his career in valve automation in the late 80s. He's worked with mechanical process control equipment since 1995 and has been directly working with SOFIS since 2011. Bert is currently the commercial manager for the Americas, and like I said, we'll be taken through us today on this webinar. So I'll pass it over to Bert and mute myself now. Oh, you're muted there.
Fantastic. Thanks, Braeden. And thank you for the introduction and the opportunity. And I want to thank everybody for joining and being a part of the meeting. What we want to do is we want to go over some generic ideas or what the industry we've seen it doing lately as far as how they're approaching manual valve operation and manual process operation, and some of the other components that might be associated with that. SOFIS is a merger of two companies, and some of you who've been around for a while may very well know them by their other trade names, which are Smith Flow Control and Interlocks Safety Systems. Smith Flow Control has been around since 1985, and Interlocks Safety Systems since 1993. In the late 90s, early 2000s, Smith Flow Control was purchased by Halma Holdings, and in 2009, Interlocks Safety Systems was also purchased by Halma, and in 2016, we merged to become SOFIS and offer the same global support and infrastructure that we have always relied on with our customers. What we're going to walk through today is we're going to walk through the concept of automation solutions that may not fall into your traditional valve actuation bucket. What it'll be is we will look at alternatives to operating valves either remotely or with portable actuation. What we're also going to look at is why. We're going to look at the why of how those pieces are being brought into it, not only what they are, but where some of the global leaders in safety are putting it into their design and engineering practices, and how human factors applications fit into those pieces. The first thing I want to do is I want to say that where we look at it is there are two different veins on our drive system applications, or you've got remote operation that is moving the operation from an unsafe location from an ergonomically unsound location to a safe or ergonomically correct location. And then there's portable actuation, which is actually physically actuating a valve easier and making operations a little easier to operate that valve. What do these products do? What does this technology do? Is it improves the efficiency of operating personnel, and it reduces the risk of repetitive stress injuries or awkward position injuries that could come into play. It also helps with the changing workforces, with some of the other things. Everyone's evolving their design and engineering practices around human factors engineering and some of the other current buzz terms in the industry. And what this does is this helps create alternatives to that kind of application. What are the current DEPs? And everybody has a standard, and I'm sure within your respective companies and organizations, there is a standard practice for operation of different things, whether it be valve or whether it be ergonomic use of space. And in some cases, it's even as simple as how desk components are set up. But what we do is we take that and we utilize it in an industrial marketplace. What we're looking at, and in some of the DEPs that we have reviewed, valves are set up as a critical set up by their criticality, which is related to the frequency of operation, the criticality in the operation, and the size and need of operation of that valve. And in that, people will determine whether it is a very critical valve, which either needs a direct dedicated actuation device, or whether it can be used with a portable actuation device. And then it goes down to where there might be an infrequent operation where there may not be that much of a need. One of the things that a lot of people will look at is, and I was raised in the industry, like Braeden said, I've been around since the 80s, and we always operated off of a 100-pound rim pull cracking force or operating force. And that is the amount of force exerted on the outside rim of the hand wheel. And if you look at, and all of this information was pulled from existing DEPs, and currently the only way that you can get the 100-pound rim pull that's listed here is only when you're breaking that valve off the seat. Once you start operating it, then it is suggested of a 33 foot-pounds of force applied to the outside rim. And this at first caused me a little concern because it seemed extremely low. But if you put that in the perspective of what your company has as a minimum solo lifting weight, most facilities use 50 pounds as their guideline. So when you put a 50-pound limit on how much you lift, then it makes more sense to put a 33 foot-pound limit on how much force you can exert on the outside rim of the hand wheel. There's also mention in some of the manual valve design and operations and process is how many turns you can have to utilize that. And most people look at 100 rotations. So if you've got a valve that exceeds the number of amount of force you can apply, but you put a 10-to-1 gearbox on a valve with 40 turns or even 20 turns, then you've just exceeded that number. And then how you manage any torque or reaction forces is also critical in that piece. And what you will see, and again, this came out of a physical DEP from a major player in the industry, and we are looking at only being able to exert 100 pounds of force on the outside rim of the hand wheel when we are actually following it through. And this is just an example of decision tree that gets you to, do you need a dedicated actuator? Do you need a portable actuator, or are you good across the board? And so it just walks people through that valve criticality. One of the other pieces we look at, and I don't know how every other customer is done, how your specific sites are done, but a lot of people are starting to move away from the concept of chain operators because of an inherent risk of either being directly flow or below the valve itself, or having to deal with the potential of the chain operator to fall off or slip, or any number of things. So people are starting to move away from that. And if you can get out of a situation like this and not have to stand in that mess, it's generally pretty good for you. What I'm going to do is I'm going to ask Sam to go ahead and initiate the first question in the poll, because what we're going to talk about is we're going to talk about our product, the FlexiDrive, which the FlexiDrive is actually an alternative to the chain wheel. It doesn't replace every chain wheel that you've got, but it does give you an alternative that allows for you to get out of the potential harm's way. We can be up to 100 feet away. We can go through walls and other types of barriers. We can even have submersible where you are below grade, which in a lot of cases you don't see the capabilities of a chain wheel to be able to extend to these other applications. This piece of equipment is made up of three main components. You've got your operator station, which is mounted in a location of your choosing that can be either on a pedestal, it can be on a concrete wall, it can be on a handrail, wherever it's operationally convenient to the operator to be in the proper ergonomic position, as well as out of a splash zone or harm's way of any kind. And then you've got the valve station, which is a direct mount onto the valve, allowing for that operation. Essentially, we are replacing the hand wheel for that operation. Then you have what goes between the two, which is a flexible cable. It is a helical cable. I'm not sure, the easiest reference I've always had is boat steering. There's a Teleflex cable that goes between a center console and the rudder. And what this does is it's the same thing as fly-by-wire or drive-by-wire technology. It is a direct link back to each other. And what this is this is a much more robust and sturdy cable that allows for operation in an industrial environment. We do have indication, which if you are not in line of sight of the valve, you will have an indicator on your operator station that allows you to know where that valve is in its position. Everything is fitted in a bespoke manner that allows for almost a belt and suspenders, because essentially what we've done is replace the hand wheel and fitted the operator station in the exact same way the original hand wheel was, whether it's with a nut or some sort of a bolt-on assembly. And then we also have an additional assembly at the bottom that allows for a belt and suspenders type application. So the risk of having the operator station fall off or create any sort of issue is removed from that application. As you can see, in a lot of cases, what we're really looking for is, one, this is an ergonomically challenging position to put a valve in. But on this other side of that, there's also a containment barrier here where you might have a hazardous liquid or a hazardous environment. So what we can do is we can get the operator outside of that hazardous environment and in an ergonomically safe condition to be able to operate it. This next slide will show you essentially how the FlexiDrive operates. And you can see the cable is wound. It's not intended to be cable tray neat. It's intended to be free flow.
Valve's going in the open.
But it allows that operation. You can see how sturdy that is on the valve itself. There is no flexibility that it would indicate that it could fall off at any given time. And that's how our FlexiDrive operates. And I would invite anybody that has questions to go ahead and put them at any time in the Q&A side so that we can answer any of those questions. What we'll jump to now is that was remote actuation. That was the operating principle that gets us to move the operation to a safe or hazard-free area or ergonomically safe area. What we're going to move now to is what we call portable actuation. And these portable actuation devices, what they do is valves that inherently don't meet the criteria for dedicated actuation, what we can do is we can make it a little easier. And what does that look like? That means that a single individual can operate a valve with a much quicker operating time than anything else. There's no need for cheaters, chains, helpers, and it's a single man operation. With our power wrench, you can see that it's set up as a safety mechanism because there's a dead man switch in the center, and then there is a throttle on the end to allow you to control the air supply going through the tool. And so what that does is that ensures that you are in a proper stance and properly prepared to operate the power wrench. And the power wrench, you can see, excuse me, you can see right here the very tail end, and it should be on the next slide, but this is what we call our drive plate adapter, and it is a simple bolt-on to the existing hand wheel. And this is what it looks like. And again, we have a few different sizes depending on hand wheel dish, hand wheel size, and stem rise that allows for us to accommodate different applications. And so there's your operating mechanism, and that's all it takes to operate this piece of equipment. Then you have your protection skid or a filter regulator lubricating pack, which has adjustable air supply. You can control, you hook up plant air to the outside edge, and then you can adjust that air supply to be able to operate that piece from there. And then you have the tool itself, which comes with a hand guard and protection items to help ensure safe operation of the tool. The tool is capable of putting out close to 400 foot-pounds of torque, although we normally on most manually operated valves, 200 foot-pounds is usually the listed requirement that you would need. And that was a quick run through our power wrench tool, and what you'll see on the next slide is the power wrench in operation. And then if, Sam, if you could go ahead and do the second question, because the second question is really kind of more based off of it really could apply to both the power wrench and EasyDrive because it applies to our drive systems and making life easier for the operator. But what we've got is the EasyDrive is a more identifiable, easier application because what we do with the EasyDrive is it has a reaction component that is built in, and it is as simple as carrying a hand tool, similar in size and functionality to an impact wrench, but with some safety aspects built into it, out to the valve and operating it quickly and easily through various different operating mediums, which would include electric, battery, and pneumatic operation. And what this is the way that it works. The reactive components that come into the operation will be exerted when this valve gets to a stopping point, exceeds the torque that the tool is set at, rather than those reactive forces going into an operator's arm or shoulder or other aspect. What happens is those reactive forces are reintroduced into a stable, secure location so that there's not any risk of injury to an operator. And where we normally will see this is these are used in applications where detailed engineering did not call for the criteria to meet a dedicated actuator, but there might be a requirement where there might be 2 or 3 operators that have to go out and operate an individual valve. And so what this does is this takes that operation and simplifies it considerably. And we can, the tool can be mounted either directly onto the top of the valve, or we can fit it to the hand wheel, or a gearbox, or whatever that necessary piece is. The key is to have this reactive component installed so that should the tool seize up for one reason or another, all of those reactive forces are exerted back into the valve, making it a safe operation, single-handed operation for an operator. We can exert up to 700 foot-pounds of force with our pneumatic tools, and up to 500 foot-pounds of force through our battery tool. Our battery tool is currently certified by the manufacturer up to Class 1 Div 2 groups A, B, C, and D. The next slide will show you how the EasyDrive works. This is a one-man operation, and being with you're not going to see the full operation, but it would be a much longer operation than if you were having to do it by hand. And that's what we try to do, is we try to make the operation of these manual valves that either are high torque or the torque's been lowered by putting on an auxiliary gearbox. It still increases the number of turns, so you might have a great deal of turns on that valve. And those are this is the last piece of our what we call our drive solutions. And this is our VPI, which is our visual position, valve position indicator, and it is designed for multi-turn valves. And what it allows you to do is, without having to put separate targets on a stem or any of the other creative engineering that's been necessary in the past, what this does is this allows for you to mount a single piece of equipment onto the top of the valve and retrieve indication back on the operation of the valve. It comes in either aluminum or stainless. All of the switches that we can provide, I believe we've got up to 14 different switches that we can provide with the unit, and those switches carry full certifications. The box is a general watertight box, but we can add an explosion-proof junction box at the bottom that would allow it to fit in any application you might need. And now we're going to step out of our
sorry, Bert, just one quick question came in. How long does it take to set up the EasyDrive mechanism?
The EasyDrive mechanism, I have been doing this, and I have done this as a demo, because what I normally will do is a demo, and I know some of the CGIS team has been doing some demos lately with some of our equipment, and I have gotten to where it will take me with my kit. I can usually set it up in 30 to 40 minutes on a valve. The intent is that when you build that, when you use that technology, the intent is that you will have a adapter kit for every valve that is critical to you. You might have one or two extras that you can install for turnarounds or something like that. But the intent is that all of these adapter components are already there, and the operator just needs to walk up with the tool and operate the valve. But it usually takes about 30 to 40 minutes to install the reactive component onto the valve. I hope that answers the question for whoever had it.
Perfect, thanks.
The next piece that I want to jump into is moving to our process control. Worldwide, it is termed as key interlock technology. But what we have found is that the America's market, North and South America, generally when we use the term interlock, the interlock is confused with an electrical interlock because there are so many different electrical components that have interlocking capabilities. So we have termed, and it actually came out of a term that I'll show you in a minute out of a book that references our product, but captive key technology, because what this product does, what this concept is that what we can do is we can take a manual process and control the operation, whereas lockout, tagout, everyone's standard car seal or lotto program allows for operational control of a single valve. What this technology allows for is process control over a breadth of valves that can be up to 10 or 15 valves long or more. The level of control is up to the site specific persons. And Sam, if you could go ahead and put the last poll question up. What we'd like to do is look at this, and on this next slide, and I don't know, forgive me if it's automatically starts, but this next slide, I think that Sam will probably send a follow-up that will link to our
valve
YouTube channel
interlocks are used to avoid
because what this is, and this is it's a longer video, it's about a 2-minute video, and I don't want to necessarily waste everybody's time looking at the video. But what this does is this looks at pressure relief applications, which is globally probably our largest application that we experience, because the worst thing you can do if you've got multiple relief valves in a train is to isolate that relief path and create a position where you're in an overpressure situation. And so what we do is we install devices that allow for control of that application. So this is what the item looks like, and this is how it will be applied. And if you can see, there are 2 keys, and the way that it's designed in a very simple format is that at one end of travel, one key will come free. At the other end, the other key will come free. And that key will transfer to the next step in the process. Or you can't start that process without a permit to work that comes with the operating key. And where this becomes very useful, is in layers of protection analysis. Because what everyone looks to do is you need to mitigate risk. And where this comes in is you're beginning to mitigate that risk and utilizing this type of equipment to mitigate your risk in that operation. If you are looking at the hierarchy of risk elimination, the ideal would be to eliminate the risk, substitute for the risk, isolate the risk. And then you've got engineering and administrative controls. You've got full dedicated actuation with electrical interlocks that can be very cost prohibitive, or you've got lockout and tagout, which is leaves room for error by human factor. What we do is we bridge that gap by allowing for an engineered piece of equipment to be put on a valve and allow for that to be administratively controlled. All of this can be found in the initiating events for independent layers protection, or LOPA analysis. And this is where our product is this is actually exactly where we are. And it allows for two layers of protection, which means a multiplier of 100 based on your application, which if you look at this risk matrix, what we're doing is we're taking you from one level to allow you to move two levels instead of a single layer. So it allows for two levels of risk application. Now what we've got is some of our typical applications globally, and we will run through this hopefully relatively quickly so we can get to any other questions that might be out there. PSVs, worst thing you can do, especially in a dual relief situation, is to isolate both paths of pressure relief. So this product would ensure that all of your that you always have at least one path open. We also in changeover processes. One of our larger applications that we've seen, especially recently, is when you're regenerating a filter bed. And usually your process application is at a higher pressure rating than your regeneration pressure. So what we do is we manage that so that you can't ever be in regeneration and process at the same time. In pump isolation, and this in a lot of cases can be more financial, but what we'll see is if you deadhead or cavitate a pump, you can burn up the motor in the pump, and that becomes downtime that is very costly. And what this product is capable of, in a very simple terms, is we can ensure that your manual suction valve and manual discharge valve are both open prior to being able to turn on the pump. Same for heat exchangers. We can ensure that the pressure protection is available and set up so that you are not ever in a situation where your heat exchanger will exceed the necessary pressures that it's designed for. Launcher receiver applications. The worst thing you can do is open that vessel under pressure. And what this product will do is it will guarantee that everything else has been isolated and that it is fully protected prior to gaining entry into the vessel itself. Or in small batch operations, or in an area, and I was actually on a call this morning where the customer is taking ethylene out of tankers and trying to move it, but ensuring that their path is always set up so you have the correct valve. And I think in this case, someone had gone out and turned the wrong valve and created an incident. This is actually out of a study that was done by the Chemical Safety Board. And what we can do is we can ensure that they have to go to the correct valve to perform that operation. The beauty of it is all of this can be done without any additional piping or engineering. It is a simple guideline based off of your PNIDs or your standard operating procedures, and then a collaboration between ourselves and process and operations and maintenance, even in some cases, to ensure that the system that we can provide meets all of the goals of all parties involved. And then it is as simple after that as replacing the hand wheel on the valve, which our team is very capable of doing. And so that's really, in a nutshell, what we do as Sophists. And what our intent is to make sure that everybody gets home safely, that there aren't any inherent risks built in based on manual operations or process operations. And I breezed through that because I was concerned about time, but are there any questions?
Great, thanks, Bert. I can ask you a couple that have come in while we were talking there. One, we answered the one there, but can I install my own FlexiDrive? It's a question. Yeah.
And that is, the FlexiDrive is designed to be self-installed. What we normally would recommend is either utilizing the service team with CGIS or our direct service team for any initial installations, let's say first time through type of thing. And that way it becomes an on-site training for somebody in maintenance to be able to install the next one. But as a general rule, yes, it is designed to be installed. We've got a very comprehensive IOM that will walk through every step of the way.
I'm gonna chime in, Bert, if that's okay, and just I'm gonna be kind of the lame one in the room, but if you do not use either a Sophist technician or the fine folks at CGIS to install and set your FlexiDrive, we can't guarantee that the open and close indication is going to be correct, and we also can't guarantee that your tension is going to be correct. And what that means is that if you guys decide to install it yourself and something goes wrong, you might be a little bit more liable for it. That's what it means. So we highly recommend that you use CGIS for the measurements and the installation. So party line, somebody had to say it.
Yeah, fair enough. All right, thanks, Janine. Yeah, and our service team continues to grow across Canada here at CGIS, and happy to help any of our customers. We've done a number of measurement pre-measures and installs on the FlexiDrive, so happy to help you guys there. There's one question that I think disappeared, but Bert, the gist of it was in terms of, I think it was a reference to the Easy Drive and maybe the FlexiDrive as well. Is there any additional maintenance plans or things that need to go along, or have you had that experience where it's now new, you're adding a new component to the, I guess, the process, and a customer needs to consider maintenance?
As far as there are maintenance applications for our equipment. It is not anything added. I know that what we generally would look at is the frequency of operation. I believe our FlexiDrive is required every 500 operations or 6 months, maybe a couple of a little bit of grease added through the existing grease cert, just to keep it well lubricated. And then as far as the Easy Drive and the power wrench, making sure that all of the fittings are tight before you operate it is really the only piece. The Easy Drive is a calibrated piece of equipment, and so there are applications where that tool needs to be managed in a way that will not allow for it to be left out in the rain or left out in the weather, because that can damage it. It has to be cared for like a calibrated piece of equipment.
Thank you. Another question just came in. Are there different type or kinds of captive key locks, or just one model?
There are quarter turn and multi-turn captive key locks. And what we can do is we also have configurations where we can do nonlinear sequencing. We can do solenoid key release. We can create temperature permissives and pressure permissives. We can do a lot of the other applications. And so what that gives us is the flexibility to essentially adapt to any application you can have.
We also offer interlocks that are specifically made for motor operated valves, bolt locks, other kinds of sort of specialty closures, actuated locking systems, you name it, we've almost certainly done it. Beyond quarter turn and rising stem.
Right. Maybe could you guys speak to how you work with the client to come up with a system like that?
Well, what we'll do, and that's where we'll look at the existing SOIP. What is your standard operating procedure, and then we'll also look at any piping diagrams that we can get our hands on, so that we can identify where the envelope. It becomes almost a mini HAZOP or risk assessment, because we're looking at all the potential instances where there might be a problem, and are evaluating that, and then we will design a system and then work back and forth with the customer to ensure that what goes in is not locking someone into something negative.
Thank you. Just back on the captive key locks, what happens if you lose a key?
If you lose a key, generally, one, it's a significant piece of stainless steel, so it's really hard to lose. But if it happens to get lost, we offer either duplicate sets. We can do a master per system, and we also have the capability. Our manufacturing facility is in Alphen on the Rhine in the Netherlands, but if the replacement key can be managed and manufactured in 4 hours, and then it's the shipping that's usually the longest term. But I have turned replacement keys in 24 to 48 hours if you're in a situation, or we can always ship one. We have master sets here in Houston, and we can always loan one out while a replacement key is being made.
But the thing is, my hand for size, these just don't go missing very often. Additionally, we built that into the system. So when we sell you a captive key interlock system, we're not just selling you a piece of metal. There's a lot of engineering and thought and problem solving that goes into it. So just adding on to what Bert said, we're going to make sure that each system comes with either a full set of duplicate keys that are to be kept under control so that they don't have the potential to go missing, and or a set of master keys. So just want to reiterate that. And Bert, correct me if I'm wrong, but we've had 6 inquiries for replacement keys or missing keys in
I
2023?
know that we've only had one instance where they needed it immediately, and we were able to answer that call in less than 24 hours. I know that as far as replacement keys, usually it's in a revamping of a system. But you're right, I don't think I've seen more than a handful that people have ever truly had an issue with.
That's good. Quick question about slides being available. Yes, we'll be sending out Sam will be sending out a couple things after the presentation is done. All right, a couple other questions that have come in. In a safety critical valve application, fire suppression, or maybe HF mitigation, how would you handle that, and how far away can the operator be from a hazard location like that?
The FlexiDrive unit is built to be as straight and as close as possible to the operation. However, we do have the capabilities to go up to 100 feet or 30 meters away from the valve. But that would be because of the efficiency lost. It would be a situation where what we would need to do is we would need to look at the valve, look at the application, and evaluate the safest appropriate distance we can be from.
So yeah, and Braeden, I think the answer to that question, safety critical valves for these, what are they're called active protections, where something has to be done in order to address the emergency situation. So if a fire breaks out, the water valve has to open in order to suppress the fire. If there's a hydrofluoric acid release, again, it's a water valve that has to open. So what has happened, as documented by the CSB in the US, is when those emergency situations happen, whether it be a fire or a release or whatever, automated systems can fail because they lose power, because there is an emergency. So having a manual backup is, I think, very important. And I think the FlexiDrive really answers that.
Right.
We've just gotten today an email that we can service valves and provide torque up to 500 Newton meters. And I have not had time to do the math to translate that into foot pounds, but that's a lot. And so it's a very robust system. There's been a lot of improvements. And like Bert said, we can go up to 100 meters depending on your application and depending on your fire zone or the dispersal area, if you're dealing with a release, whatever the hazard is. There's, I would say, at least a 99% chance that using the FlexiDrive on that active protection system, those active valves, is going to be a great way to ensure that you don't have any gaps in your suppression systems and active protections. Does that answer your question? Did that make sense?
Yeah, that's great. Thanks. Another one, this came in, follow-up question, I guess, on that is there a possibility that the remote FlexiDrive mechanism can break? I guess the answer is it's always a possibility, but do you want to speak to sort of the reliability of the FlexiDrive?
Yes, if the FlexiDrive is installed properly and is sized properly, like Jenny said, we can go up to 500 meters, which should be, if at a 3/4 to 1, should be around 375 foot-pounds. At that point is when our cable crimp will fail, which creates a situation where you've separated the ends of the cable. That would need to be replaced, and that is the built-in failure point so that we don't damage valves or any of the other equipment. So all that needs to be done is replacing a cable. And that is, it is something that happens, but if the sizing and the setup has been done properly, it shouldn't happen. It's a very rare situation where someone over torques a valve or tries to utilize a valve assist type mechanisms to be able to operate it.
Thank you.
Yeah, you can break anything if you try hard enough.
Yes, it is very true. All right, perfect. I think that is all of the questions. Bert and Ginny, thank you so much. Is there anything else you guys want to add before we say goodbye to everybody?
I just want to thank everybody very much for having us. And I failed to introduce Jenny, who Jenny is one of our sales managers that covers essentially the Midwest all the way to the West Coast. And then she also is responsible for Mexico and South America.
All right. Thanks. Hi, Jenny. Thanks for joining. There was one more question that came in. We'll just answer that now. We've got a few more minutes. Any recommendations on inspection timeframe for the FlexiDrive?
I would put it on generally, and it's the same thing that we would use with our interlock devices. Frequency of operation and type of environment that it's working in would relate to a PM schedule that would similar to what you would do on a normal valve in those situations. If it's a high vibration area, you might want to check for bolting. You might want to check for operational constraints. If it is a low, very clean, simple operation, once every couple of years or once every 18 months is well within reason, and it's not necessary outside of that. Everything is designed to be relatively maintenance free, but as we know, in an industrial environment, everything needs a little care. And so logical PM on a schedule that's consistent with other equipment in the same type of environment.
Thank you. And the helix drive itself is well protected inside the sheath.
It is absolutely protected, yes.
Yeah. Yeah.
And I know that CGIS has a data sheet on the FlexiDrive that they can send out, which gives all of the critical data on what it's rated for, because I know that we can go up to 350 degrees Fahrenheit in the environment, and that's the point where the conduit will start to melt. So those are the pieces that that can be supplied if on request.
All right. I think that is it. If there's any more questions, like I said, Sam will be sending out a follow-up email. Thank you all for participating today, and a big thank you to Bert and Ginny for putting this on, and big thanks to Sam always for organizing these. Well done, guys. So for all everybody else, give you back 9 minutes today, and enjoy your rest of the day and be safe. Thank you, everyone.
Thank you, Braeden. Thanks everyone for attending.